Hello everyone, this is Reza. Welcome to another video of VFX Series. In this video, I'm going to go through basics of nCloth system in Maya. Now, before we get to how to use nCloth for characters, we need to know basic rules, all the guidelines, and all the important nodes and attributes in order to apply them to a hard surface model or an organic character. Now, because of that, I thought it would be a good idea to just record a video and just talk about all the basics, all the theory behind nCloth, the introductory session and important attributes. And only then I do have a video that I go through how to apply what we already know onto a character and create fabric clothing for a character. You can click on the top up banner to watch that video if you already know the basics. Now, without further ado, let's dive right in. Now, when you create an nCloth, you should be aware of a few guidelines. You can only create nCloth object from a polygon mesh. So we have, as you know, if I go to create, we have NURBS primitives and volume primitives, and they're offering fantastic tools to generate models. But if you were to go that route, then you have to make sure to go to modify, convert, and convert your NURBS into polygon. That's the first rule. The second rule is you preferably want to start with rather high resolution model. You can down-res the model as a proxy, nCloth that proxy, and wrap the format to the high resolution. But the end result needs to be high resolution because high resolution mesh creates high quality collision. So all the wrinkles and the folds are going to look more realistic. The third rule is not to have any n-gon or non-manifold geometry in your model. Preferably as fewer triangles as possible, because long skinny triangles are just a headache when it comes to nCloth. To test that, you need to make sure that you're in modeling. You go to mesh, clean up option box, and you need to make sure that concave faces with holes and non-manifold geometry are checked. If you go clean up for my nCloth simulation. Now, the last guideline is not to change the topology of nCloth when it comes to simulation. So if I were to find out about this problem halfway through nCloth, I'm afraid I'd have to start over. You cannot grab a multi-cut or insert edge loop halfway through your nCloth simulation and change your topology. If you do that, the entire nCloth simulation will be broken. And you completely will lose the collision between the collider and the nCloth mesh. So with that in mind, let's get into how to create nCloth. Now, once you generate a nice evenly spaced quads as your target mesh, then you need to make sure that transformation all cleaned up. So you can go to modify and freeze its transformation and delete by type history. So the mesh needs to be as clean as possible. And you need to make sure that you're in FX menu set. And we do have an nCloth drop down here. So you click on nCloth with the model selected, you go and create an nCloth. Now, once you create that, you will receive two nodes in your outliner, a nucleus 1 node and nCloth 1 node. Now, before we play or go further, let's explore what these two nodes are. I'm going to, with nCloth selected, go to Windows and Node Editor, and I'm just going to select the nCloth shape and expand the nodes. Let's have a look at these nodes and explore what they're doing. Now, upon the creation of nCloth, Maya is going to go ahead and it's going to hide this node. It is really important to understand how nCloth works to avoid any confusion. What we see after creating nCloth is no longer fabric, but the output mesh. So if I were to have a look at this scene and just click, although I still see fabric in my outliner, the reality of the matter is I'm looking at the output mesh. Now we have time associated to our solver, and we have nCloth shape. And this node is in charge of the behavior of the cloth. Basically, you define thickness, rigidity, and how you want the nCloth to be perceived as a fabric. There are a long list of attributes that you can change, as well as a good amount of presets to get you a good start. Now, Nucleus node, on the other hand, is the solver for your simulation. It solves and calculates how nCloth interacts with other objects. It defines collision, and it gives your simulation accuracy and a look. Also, all the force fields such as gravity or wind will be applied to the Nucleus node, since this node simulates everything in your scene after all. So I'm going to close that window and let's play. You can see the cloth just falls down rather slowly. I'm going to make sure that in my preferences time slider, play every frame is selected, because Nucleus node cannot just calculate once every 24 frame. It needs to be calculated every frame. But still, if I play, the cloth falls down. The falling down part is due to Nucleus node and the effect of gravity. But the reason that it's not holding on to the hanger is because we haven't defined any collision. Basically, nCloth doesn't know how or where or what to collide with. That's why it is important every time you create nCloth, you need to think about a collision object as well. And to be fair, if I zoom in, having a clean collision object is as important. With the collision object selected, I'm just going to go to nCloth and create a collision through Create Passive Collider. If I go to its option box, Maya asks what Nucleus node you want to choose for my collision. You can either choose the existing one, which is obviously the good choice, or you can create a brand new one. I'm just going to go Make Collide. It looks for any nCloth geometry and creates that nRigid node, and that nRigid node defines the collision. Now if I zoom back and play again, you can see the cloth collide with the hanger but eventually falls down, simply because there is not enough friction, not enough accuracy in our simulation, so on and so forth. You can even make the ground plane a collision object, or even better, if you go to Nucleus and scroll down, this ground plane is the grid here. So I can just enable the ground plane, define some bounciness friction to it, and when you play, it actually falls on the ground and collide with that invisible plane. Obviously, another option is to make that polyplane a collider, but since these two are exactly on the same level, I'm better off with just a simple use plane attribute. Now, it would be a good time for me to talk about scene scale as well. I do have a measurement tool that I would like to make visible, and you can see this measurement tool shows about 8 cm for my cloth. While 8 cm is fairly small, this is not going to work for my scene, because the way that nCloth sees things is 1 unit is 1 meter. So technically I don't have 8 centimeter fabric, I have 8 meters of fabric, which is massive. So what you can do to get a much realistic result is to go to the heart and to the brain of the simulation, which is nucleus node, scroll down into scale attribute, and we have space scale, which is 1 unit 1 meter. You can just reduce this to something like 0.2 and get a much realistic behavior, a more natural speed, if I may. Now let's start with our nucleus and explore important attributes. The first one is gravity, and 9.8 gravity is physically accurate. You barely want to change that, or the direction, which is -y, unless there's like a turbine underneath and pushing the cloth in positive y, or there's a specific reason that you change the direction of your gravity. The next one is air density and wind speed. I'm going to select the cloth, and from the nCloth menu, give it a preset. There are a long list of presets that you can give to this model. You can give this a heavy denim, and that gives it mass, makes the cloth heavier. And you can see the amount the stretching is just ugly. And simply the collision cannot hold the cloth, but when the cloth falls, it falls rather with not much wrinkle. So it holds and preserves the look of the cloth. For now, I'm going to pick a t-shirt, which I find the attributes are happy medium. It puts you off to a good starting point, especially if you are simulating a t-shirt after all. Now, in order to hook the shirt to the hanger so it won't slip off, we need to constrain it to that model. And that brings me to a very important concept, that every time you create nCloth for organic model, you need to have some sort of a supporting strategies. In a physical environment, in real life, this cloth may hold on to this hanger and may not fall down, but in here, due to high gravity and lightweight for this shirt, it happens. So one trick is to use nConstraints to somewhat tame the behavior of this nCloth node, and there's a long list of nCloth constraints. We have component to component, which connects to vertices or to faces. We have point to surface, which connects a point or vertex to the entire geometry. We can just slide a model onto a surface. Just think of it as a boat in a turbulent ocean. We can make the surface tearable and create tear on the geometry. Or we can just make use of a simple pin and pin the model in space. So just to demonstrate how simple this is, I'm just going to select a few points. If I were to go transform, constrain, Maya creates a dynamic constraint node and looks at all these vertices, and through a invisible locator, it's going to pin that into space. So if I press play, Maya is trying really hard to constrain that geometry so it won't fall down. But again, it's a good starting point. Now, knowing constraints are absolutely helpful to control the way that the cloth behaves. At the same time, I want to be in nucleus node and increase my substeps. Now, substeps are very, very important, and they define the number of times that Nucleus Solver calculates a geometry per frame. Now, if your object is moving really fast, then you have absolutely no choice but to increase the substeps to a very high value. And with that comes max collision iteration, which enhances the accuracy of the collider and the collision geometry. So for now, I'm just going to increase that to 10 and 12. I also found out that 0.1 is a bit too high, so I'm just going to increase my space scale to 0.3. And I reduced my gravity instead of 9.8 to 0.98. Now if I play, you see that the cloth holds beautifully. It won't fall down anymore. Well, it tries its best, and we see a little bit of stretching happening, but there's not enough gravity to really pull the geometry down and tear these areas. So your simulation won't explode. Now let's go to our nCloth and explore some of these attributes in here. The first rollout is collision. Now, how much collision you expect to see? If I go to Solver Display and switch to collision thickness, you can see it actually defines the collision layer. You need to make sure there's no inner geopenetration. You need to make sure there's no area sticking out. And usually I found out that this actually defines the thickness of your cloth. So if your cloth is that thick, then it looks okay. But for the most part, to me, that's a bit unrealistic. I'm just going to lower this to something like 0.005. And to me, that's a more realistic thickness for my cloth. If your cloth sticks to a point, then you can just reduce this number to something like 0.2 and reduce the amount of friction. We have in dynamic properties stretch resistance and compression resistance. Now for stretch resistant, a low figure will make your nCloth very stretchy. So if I set this one to something like 5, I'm going to actually turn off the collision thickness and turn off the wireframe on shaded so we see the geometry. If I were to play now, you can see the geometry stretches quite a fair bit. And usually for nCloth, you need some sort of a pre-roll for the cloth to settle before you simulate it, because it keeps stretching and you don't want this to happen halfway through the act. It will basically ruin the animation. So this figure changes based on the presets that you have, but again, I found out that although it gives you a good starting point, you always find yourself in a situation that you have to go and tweak it. The contrary, if you bring this figure too high, then it sort of backfires on you. So if I go ahead and click play, then the geometry looks just way too rigid now. So it really deforms at all. Unless this material is leather, there's no way that you kind of have this sort of very rigid behavior from a cloth. Now I'm going to bring this one back to the default 35, and the next one is compression, and it's as important as stretch resistant, and they usually go hand in hand. And that compression resistance defines how the geometry deals with external forces. Usually a low figure makes your nCloth crumple under pressure, while the rather high resistant figure will make your nCloth resist crumpling, basically. So it won't fall, it won't collapse. Now, if you want your nCloth to behave like a rubber band, then you go ahead and disable this attribute, and you won't be able to see much of a wrinkle on it. It's just a springy rubber band that goes up and down, and those type of surfaces are very difficult to settle, so they never stop moving. So value of 10 would be a good figure, and the highest you go on this is usually 100, not over that 100. Now, if you're creating an effect like a tablecloth, then that bend resistant is very useful, because bend resistant, if you lower it down, it allows the corner of your cloth to be bent with not much resistance, and it creates a really nice fold to the scene. Although you may think 0.1 is a low value, it's actually not for this attribute. You can lower it as low as 0.05. I found out that this value actually adds to the appeal of my nCloth simulation and adds really nice wrinkles to the geometry. So make use of that if you want. Now, we don't have too much force field in here, so I'm just going to go to wind and introduce a little bit of wind speed in X direction. So I'm just going to set the wind speed to 5 and enable my interactive playback. And that's really a nice thing about that interactive playback, that I really don't need to play anything. It just interactively shows how the cloth deforms. The good thing about using wind or air density is they're internal forces, so you don't need to actually go to force field and add an external force field. It's much faster to calculate because it's an internal nucleus node. Now, as soon as I do that, you see that we run into some inner penetration collision problems. Now it's time for me to explain. If I go to nCloth, self-collide, and self-collision and collision flag. Now, usually if you're aiming to get good results, I set this to full surface, and in my quality setting, I increase my max self-collide iteration to a high value, something like 8 or even 16. And I'm going to go and check trap checked and self trap checked with a push out of 0.1, and it makes sure that if there is any self trap problem, the system tries its best to push out the geo inner penetration that you may get, and the push out value to 0.1 usually works. Now, if I were to just play or use interactive playback, I may have a difficult time seeing this because it's just way too slow and it doesn't give me an accurate representation. And that's why every time you want to see an nCloth, it's better always to cache it first. It creates a temporarily physical cache file on your disk, and only then you can kind of scrub through and see what's happening. In order to do that, you select the geometry, you go to nCache and you create a new cache nObject option box, and you name it for the whole time slider, and you go create. Now my cache is done, and if I bring this over, you can see Maya is creating physical cache files on my computer. At any point of time, you can go ahead and delete the cache. If you relocate the cache, you can go ahead and append to cache or attach a cache to just reconnect the link. But this gives me a really good opportunity here to just scroll down and see how it moves. Now, I would like to demonstrate how to paint vertex map influences on your nCloth. There are many ways that you want to target only a region of your nCloth and change its attribute. For this one, I would like to make this or turn this to an nCloth. I would like to select these three hemispheres and make them passive collider. And if I play, technically the cloth should interact with the colliders. Fantastic. Now if I rewind, let's say in this example, without removing these two side hemispheres, I just want the nCloth to only collide with this central hemisphere. That would be the time for me to use paint weight on my vertex map. I've got a long list of attributes I can target. For this one, I would like to target collide strength. I'm going to double click on my tool settings, make sure I'm using hard brush and flood and color ramp. Now I can go and set my value to 0 and just paint absolutely no influence from my collision on the sides of my nCloth. Now if I go and play, I only get collision for the one in the middle. That is absolutely priceless. And you have a long list to choose from. You can increase or decrease bend, compression, stickiness, thickness, even friction, mass, or rigidity. So make use of this option. It's an absolutely amazing option to be able to paint areas, regions. You may want to have a stiffer central cloth and more loose surrounding nCloth. That might be the effect that you want to go for, and the only way to do that is through painting vertex map on your nCloth. Now, next example is how to use component to component constraint. So I have a nCloth mesh and it falls down, and I would like to pin that. Let's say we have a wall, I want to pin it to the wall, and also want, when I move the pin, I want the cloth to move with my pin. It's a really good trick when you want to create something like curtain. That works beautifully. So I'm just gonna select the first pin, go to component mode, select the component, shift select the other surface, which is your nCloth mesh, right click, select a component, and then you go to nConstrain. I'm gonna tear off the menu, and I'm gonna select component to component. Going to do the same thing for the second pin. Now, if I zoom back and enable my interactive playback, so I'm going to go to Field Solver with this nCloth mesh selected and interactive playback, you can see these guys are holding the nCloth. Obviously, there is not much rigidity happening here, so it's very stretchy. Very quickly, I'm going to go to dynamic properties and increase my stretchiness. And if I move, you can see I can create natural folds, and the cloth adapts itself to the collision as well. Remember, I'm using a very, very low substep, but despite that, I'm getting really good results. I can get them even closer, and look how beautiful and realistic those wrinkles and folds are. That's fantastic. Now I can select that. I can make a duplicate, and this one is rigid, and you can use it for your scene, or if you want an interactive one, you can just bring this into your scene and make use of it. A very useful one. In the next example, I'm going to show you how to use tearable surface. Now, in this last demonstration, I'm just going to show you something really cool. I always enjoy doing that when I work with nCloth. So I have a very simple scene here. This is a passive collider, and I've got a rigid body, so something rigid, and I do have an nCloth system with transform constraint assigned to it. So if I click, that nCloth actually acts as a collider and holds the ball. Very cool. Now I want to create natural tear on this cloth. So when this ball falls, I want to tear the cloth and hit the sink here. In order to do that, I need to select a few components and make them tearable. So I'm just going to select an area. And let's say I want this area to be vulnerable when it comes to tension and pressure coming from this ball. With that, I'm going to go to nConstraint and make a tearable surface. If I press play, you can see that it actually managed to tear the geometry. Very cool. Now, one thing I usually do, I try to customize my pattern. So I probably go in here and just nominate a few points intentionally. Obviously I want to deselect, and only then I'm going to create that tearable surface. Now this attribute, just so you know, comes with strength and glue strength, so you can kind of tweak around with those and see what type of result you're getting. If I now click on that, you can see it actually did the damage, but it didn't leave that obvious rectangle shape behind. It's a more natural fold, if I may, and it's quite actually pleasing to see how accurate this is. But again, you can always go and change the strength to different values and get different behaviors. I hope you guys enjoy this video, and if you want to take this to the next level, click on the top up banner and watch the nCloth for characters. I'm sure you'll find it useful and you'll enjoy it. Thank you very much for tuning in, and see you in the next video.